we are going to look at question number 10 on this year's AIME test. Okay, let fx be a 30-degree polynomial with real coefficients satisfying this nice condition. Find the absolute value of f0. Okay, look at this question here. This is really cool. And if you go to the art of problem solving website, okay, there will be 4 solutions. And I look at those 4 solutions. I'm not satisfied. Some of the answers or solutions are really messy. So I start with my own solution here. So let's go through this solution and see whether you will enjoy it or not. And I would like you to compare with the other solutions. Okay. First, simplify the problem by setting gx equals fx plus 4 over 12. So what we will do is that if we divide this function by 12, so you can replace the number 12 by 1. Okay. Then what? If we shift the x value by 4 to the left side, so you will replace those numbers 1, 2, 3, 5, 6, 7 by -3, -2, -1, then 1, 2, 3. So the problem will be simplified to be this. Okay, this is even nicer. Okay, and we need to find the absolute value of g -4. Okay, look at here. G -4, x equals -4, it will correspond to f0. -4 plus 4 is 0. So this is equivalent. And this is nicer because the number is 1. Okay, smaller the number, okay, easier to calculate. Okay. Gx is still a degree 3 polynomial. So we just say gx is ax cubed bx squared plus cx plus d, and a is not 0. Okay, g squared x minus 1. Okay, you will see that if x is all those numbers, okay, g squared x will be actually be 1. So minus 1 will be 0. So this is a polynomial degree 6. And with 6 distinct roots. So, okay, this is nice because a degree 6 polynomial has 6 distinct roots. Then it can be factored. Okay, as okay, the leading coefficient, which is a square, okay, a square, then x minus 4th root, x minus -3, so x plus 3, x plus 2, x plus 1, then x minus 1, x minus 2, x minus 3. Then what? We will move this subtract 1 to the right side. Then, okay, this will be g squared x. G squared x. The right side will be this plus 1, but I will combine x plus 1 with x plus 3 with x minus 3, x plus 2 with x minus 2, x plus 1 with x minus 1. Okay, so it's nice. And the left side is square of gx. So it's just this square here. And I don't want to expand this out, but I want some particular terms. So I want to compare here, because I see that on the right side, okay, it's a polynomial of x squared, so no odd degree terms. So I want that the x term on the left side, okay, you look at it here, it will be 2c dx. 2c dx, those two terms multiply together and it's 2. Then constant term with d squared. Then I will look at the x to the 5th power term, degree 5 term. That will be okay, 2ab, then x5. Okay, I will compare the terms, so I know that this square is x squared times -1, -4, -9 plus 1. Okay, so that's this square is -36 a squared plus 1. And 2ab, okay, just coefficients of x, y, it should be 0 here. This side, okay, contains only x squares. So 2ab is 0, that means b equals 0 because a is not 0. A is not 0. So we find out b equals 0. The purpose here is to find a. Once we find a, then okay, it's easy here. You got g square x. Then of course you can find this. So if we find a, so it will be the problem will be solved. So we find b equals 0, but we want to see whether d is 0 or not. So let's see here. So let's say if d is not 0. If d is not 0, then from here, okay, this should be 0, this term, because that's the degree 1 term. There's no degree 1 term here. So 2d is 0. That means c equals 0 because we assume d is not 0. Okay, and also here, so we have b0, c0. So b0, c0, then gx is just ax cubed plus d. Okay, if we square it, is this. Then you see that the x cubed term here, x cubed term also should be 0. Okay, should be 0. So 2ad equals 0. This means d must be 0. Okay, 2ad equals 0, but the a is not 0. So we got d equals 0, a contradiction. So we start from d not equal to 0, we got d equals 0. That's a contradiction. This contradiction says, okay, d cannot be 0. So d equals 0, d square is this. So that means a square is 1 over 36. So we find a square here is 1 over 36. Next, okay, once we find a square here, so this will be g square x, g square negative 4. You just substitute x by negative 4 in there. Okay, that is 1 over 36. It's 1 over 36, negative 4 square minus 1, negative 4 square minus 4, negative 4 square minus 9 plus 1. It will be 36. So if you take the square root of both sides, okay, then you got the absolute value of g negative 4 is 6. Then okay, you multiply by 12, you will get the absolute value of f0. So the answer is 72. Okay, you would think that 72 is the correct answer, right? Let's continue. Okay, let's not stop and actually find the function f. Okay, so we are not finished. We are not finished. So let's try to find the fx. Okay, we already know that a squared is 1 over 36. So the a is plus or minus 1 over 6. It can be negative. And we also find out that b, c, and d are all 0. So that means gx is this nice function. Okay, it's plus or minus 1 over 6x cubed. Then what? fx, okay, fx will be just multiply this by 12, then replace x by x minus 4. fx will be plus or minus 2 times x minus 4 to cube power. But look at this function, it's nice, but does it satisfy the condition in the question? No, this function doesn't work. Because if we set x equal 1, 1 minus 4, negative 3, negative 3 cubed, negative 27. Negative 27 times 2, no, it's not 12. The absolute value is not 12. It doesn't work. It doesn't work at all. So what's wrong? Okay, what is wrong? If we go back here, okay, everything is fine. So everything is fine. There's no mistake here. So this means actually there's no such function. Okay, so this problem is invalid, flawed. Yeah, you would think that those the problem writers will check their own problems, but for this problem, it's obvious. So officially, okay, any answer should be accepted as the correct answer to this question. So, okay, this is a bad example that okay, the AIME problem is totally wrong. Okay, and if you find this is not correct, if we find any mistake in my solution, just let me know. See you next time.